Okay, so today we're going to go on to Chapter 5, and we're going to start with Chapter 5, Section 1, Day 1, Understanding Direct Proportion, and you'll be able to identify direct proportion. So at the supermarket, each pound of strawberries costs $2, so that means you're paying $2 per pound. So if we look here at the picture, we have, 2 pounds of strawberries cost $4 because $2 per pound, and you're buying 2 pounds, 2 times 2 is 4. Therefore, 3 pounds of strawberries would cost $6 because you're spending $2 per pound times 3 pounds. That would be $6. And that's going to go on no matter how many pounds you buy. So the table shows this in a table form. So how many Y dollars you pay for how many X pounds of strawberries. So the weight of the strawberries, X pounds. For 1 pound, you're going to pay $2. For 2 pounds, 4. For 3 pounds, 6. So as the weight increases, your cost is also going to increase. Okay, so notice what happens when you compare the cost of the strawberries to the number of pounds. So these are now, we're writing these as a rate. Okay, so we're just looking at the table and upside down. So 2 over 1, 4 over 2, 6 over 3. You're starting with your cost in the numerator and you're putting the weight in denominator. So Y is going in the numerator, X is going in the denominator. Okay? So an equation that says 2 ratios are equivalent is called a proportion. We just talked about these in the last chapter. So 2 over 1 equals 4 over 2, and 4 over 2 equals 6 over 3. If we cross multiply, we get 12 for both, for 4 over 2 and 6 over 3. 2 over 1 and 4 over 2, we get 4. Or if you reduce all of them, you're going to get 2 over 1. You can read the proportion 4 over 2 equals 6 over 3 as 4 is to 2 as 6 is to 3. These ratios are equivalent because in each ratio, the first term is 2 times the second term. So 4 equals 2 times 2, and 6 equals 2 times 3. All right, you can see that the cost of the strawberries is 2 times the number of pounds. So for 1 pound of strawberries, 2 times 1 is 2. For 2 pounds of strawberries, 2 times 2 is 4. For 3 pounds of strawberries, 2 times 3 is 6. The cost of the strawberries and the number of pounds are said to be in direct proportion. If you let Y be the cost of the strawberries and X be the number of pounds, you can write 2 equivalent equations. So this is the constant proportionality stuff. If Y, which is the cost of the strawberries, divided by X, which is the number of pounds, equals K, or Y equals K times X, where K is a constant value, then Y is said to be in direct proportion to K. So if we go back up here and look at these, Y is the number of is the cost, and X is the number of pounds. So this is Y. Let me freeze this. This is Y. This is X. Okay, so if you write those as a fraction, 2 over 1 equals 2. 4 over 2 equals 2. 6 over 3 equals 2. So therefore, your constant proportionality is 2. Every single time you divide those, you get 2, which is exactly what they're saying down here. So for that problem, the constant proportionality would be 2. Direct proportion is sometimes called direct variation, and the constant of proportionality is sometimes called constant of variation. And they're just using the words, a different word for those, and we'll put those on our word wall on Monday. Okay, so now we get to the examples, and it says, tell whether quantities are in direct proportion from a table. A pet store owner uses a table to decide how many of a certain type of fish to put in an aquarium. Tell whether the number of fish, F, is directly proportional to the volume of water, G. If so, give the constant proportionality and tell what it represents in this situation, and then write a direct proportion equation. Okay, so they're saying fish is proportional to, let me see here. Fish is directly proportional to the volume of the water, G. So we're going to have F over G this time. Okay, so for this problem, we're going to have F over G. Doesn't matter if they change the letters on us. You just have to read the problem. Okay, so we're going to have 6 over 4 is what we're going to start with. If I reduce, sometimes you might not get a whole number, like last time was 2 over 1, which is 2. 6 over 4, we can divide those both by 2, and we're going to get 3 over 2. Then we're going to do the same thing for 15 over 10. Okay, and 15 and 10 are both divisible by 5, and that's going to give me 3 over 2 also. And then I'm going to do the same thing with 30 over 20, and that also reduces to 3 over 2. So that means that we have constant proportionality because each time we reduce those or write them as a fraction, or it could be a whole number like the last one, we divide them, we get the same thing. So therefore, to write our constant of proportionality, F equals, to get F, we do 3/2 times G. That's your constant proportionality. Okay, so let's go down to this one. The table shows, let's go back up. For y to be directly proportional to x, the ratio y-x must be the same for all ordered pairs, which is what we just did here, 3 over 2, 3 over 2, and 3 over 2. So it says be sure to check all of them. So not just do 2 and say, oh, it works. All right, so let's go down here to B. The table shows the distance traveled by a snail, d, centimeters after t hours. Tell whether d is directly proportional to t. If so, give the constant of proportionality. So we're going to have d over t. Okay, so for this one, we're going to have d over t. All right, so d is 9, so we're going to have 9 over 1. That equals 9. Then we're going to have 18 over 2, and that equals 9. And then if we do 21 over 7, that equals 3. So since all three of them do not reduce or divide to the same answer, d and t are not directly proportional. So you just write d and t are not in direct proportion. And then you're done. Okay, have a good night, and we will see you tomorrow.